Hey guys, welcome back to KIS Module 7.4. Last lesson we went over the dehydration and the combustion of alcohols. This lesson we're going to be going through the substitution of alcohols. This lesson is actually interesting because we're going to see alcohols turn into a lot of other random things that we wouldn't expect them to turn into, okay? Let's get straight to the point. So we're going to be talking about substitution. Alcohols actually undergo substitution reactions when they react with hydrogen halides. If you forgot what hydrogen halides are, it's basically H and X. So it's a hydrogen something, and something is always a halide. So that's what hydrogen halides are. If you forgot, we worked with hydrogen halides a little bit in 7.2, I believe, or 7.3. So if you kind of forgot what hydrogen halides were, try and go back and watch that video. Okay. So they can actually undergo substitution reactions when they react with these hydrogen halides. However, we need an acid catalyst, okay? What happens in this substitution reaction is that the alcohol will actually lose its hydroxyl functional group and form water, and then the halogen atom is going to replace that lost hydroxyl group. So let's write this down very quickly. Alcohols can undergo substitution reactions when they react with hydrogen halides under an acid catalyst. Easy enough. That's basically what we learned, or what we've done so far. You don't actually know how this works yet, but you will. And we just write removal of OH replaced by halide. If you forgot, an alcohol has a hydroxyl group, so please don't forget that. Okay, we mentioned before that for non-oxidation reactions, tertiary alcohols are more reactive than secondary and primary alcohols. Substitution reactions are actually an example of this. A tertiary alcohol can actually react with a hydrogen halide completely via a substitution reaction in less than 1 minute. Let's just say a tertiary alcohol is reacting with hydrogen chloride. It's going to form a cloudy white haloalkane literally in less than 1 minute. So tertiary alcohols are very, very, very reactive. In this case, tertiary alcohols are most reactive. Okay, awesome. So let's actually go through on what happens here. With a tertiary alcohol, it's going to react very fast. But if we're talking about a secondary alcohol, it will actually take about 2 to 5 minutes. It's going to have the same product, which is a precipitate haloalkane in water, but it's going to take a little bit longer. Lastly, for a primary alcohol to react with a hydrogen halide, it will actually take more than 6 to 7 minutes, okay? This is a lot longer than the less than 1 minute with a tertiary alcohol, so we can kind of see that what we've doing before by saying tertiary alcohols are more reactive in non-oxidation reactions is true, okay? You're going to do some of these experiments at school, and you're going to be able to see this firsthand, which is really, really useful when you're trying to understand everything, okay? So let's draw an equation and see what happens in a substitution reaction. So let's say we have propanol. This is a secondary alcohol. If you've forgotten how we find out, we look at the carbon connected to the hydroxyl, and that's connected to 2 other carbons, so that means it's a secondary alcohol. Let's just say we're reacting this, I don't know if that's the color I used, yeah it is, with hydrogen chloride. Note, it's not hydrochloric acid because it's not dissolved in water. If it was dissolved in water, then yes, we call this hydrochloric acid. Let's use it as hydrochloric acid today because we're going to have water in the product, so it's going to be dissolved. So let's use it as hydrochloric acid. So if we have propan 2-ol plus hydrochloric acid, what's going to happen? We actually need an acid catalyst, usually also H2SO4, but I'm just going to write acid to be very, keep it general for you guys. Acid catalyst. And sometimes you actually need to heat up the solution for a primary and secondary alcohol in order to speed up the reaction. Sometimes you put heat, you don't need to, so there's no specific figure. Sometimes you just heat it under a heating mantle in order to speed up the reaction. Let me put this in more space. Acid catalyst. Okay, what's going to happen here? This carbon-oxygen bond is going to break. So we're going to break here, and we're also going to break here. Okay, what's going to happen is this chlorine is going to replace the hydroxyl, and the hydroxyl is going to replace the chlorine. So what's going to happen is we're going to end up with something that looks like this. Chlorine plus HOH. We know that this is a haloalkane and this is water, which is exactly as, so this is a hydrogen halide, and this is an alcohol. So as you can see, it's exactly as we've predicted. We add an alcohol to a hydrogen halide, and it's going to give us a haloalkane and water. So this is a very simple reaction. It's not very difficult, and it's just a simple substitution reaction. Let's write the reactivity. So we just remember, primary will take, I would say, more than 6 to 7 minutes. More than 6 to 7 minutes. We say unreactive. Secondary will actually take about 2 to 5 minutes. Moderate reactivity. Moderately reactive. And the most reactive is obviously under 1 minute. Very reactive. So as we can see here, tertiary alcohols are definitely the most reactive. And if we put an arrow there, let's actually use let's use a deeper color. Let's go down, more reactive. Okay, so we've gone through the reactivity of substitution reactions, and we've gone through how they work. That's basically all you need to know for substitution reactions with alcohols. It's not very difficult, so we will leave it there and move on to the next thing, which is the substitution of halogenated compounds to form alcohols. So, as we said before, alcohols can be formed using substitution reactions. We've kind of brushed against this before, but we're going to go through it anyway. So this is actually a very slow reaction between primary haloalkane and water, even if they are heated. Okay, so what happens is basically the halogen atom is replaced by a hydroxyl functional group. Let's write this down. So we know we can form alcohol, so let's not write that again. This is a very slow reaction. This is a very slow reaction. Okay, so let's keep that there. We have a primary haloalkane and water, and let's put heated in a bracket so we just know it's heated. Okay, so what happens in this reaction? Halogen atom is replaced by hydroxyl. Okay, so that's basically everything that's happening. Let's go through an example. Let's use bromine this time, so we're not kind of doing the same thing over and over again. Let's do this. And we have bromine, okay? And then we add water, okay? And then we add heat, okay? So what's going to happen here? Very similar to what we've spoken about before. This is going to break, that is going to break. This hydroxyl functional group is going to come here and replace the bromine. And likewise, the bromine, this is going to break. Sorry, that's definitely wrong. Let's use the right color for that. That's going to break. This bromine is going to come here and replace the hydroxyl. And as you can tell, this is a substitution reaction once again. And we can kind of predict our product since we've done this before. And we know we're going to be forming an alcohol and a HBr, which is hydrobromic acid, or hydrogen bromide if it is a gas. Okay, so that is basically what we do to find the alcohol, which is after we substitute a halogenated compound. So that's basically all you have to know. It's not very different from the one above. It's actually the direct opposite. So I didn't leave it much space, and there is really not much to go through. So let's leave that there. And fermentation needs a lot more time than these two, so we're going to go through fermentation in a video by itself. So this is going to be the end of this video. I hope you understand all of the reactions so far. There are quite a lot of reactions, but if you really understand them, there should be no issue with going and doing these questions in an exam very, very easily and without any trouble. Thank you for watching, and I'll see you next video where we move on to more reactions such as fermentation, hydration of alkenes, oxidation, and those kind of things. Thank you, and see you soon.